I'm going to attempt this month's TMiP Animation Generation Collaboration task, which is to make an animated proof of Pythagoras' theorem. And once again, I'm going to do this in LaTeX using TikZ. So I'm going to start by doing the usual LaTeX document stuff. Right, so we've got a document building. Let's do a no indent and then a TikZ picture. And we'll start by drawing a right angle triangle. And I'm going to do a 3, 4, 5 triangle. Just because it will be simpler to work out where the coordinates will be. And let's do line width. So I'm going to start by drawing a right angle triangle and putting a square on each side. So do that by saying 0, 0, cycle. We'll put a square at the bottom, left hand side, and a square on that diagonal. So that went 4 across and 3 up. So to go 90 degrees to that, we need to go 3 across and 4 up, plus 3 and 7, because it goes through the other way. We go to 7, 4. In Y, it goes from -4 to 7, so 11.2 should be enough. And in X, it goes from -3 to 7, so 10.2 should be enough. I'm going to start by colouring in the these two squares. So let's do that by doing fill red. Oh, let's put that under the lines. Let's make them 2 different colours. There we go. So what I'm going to do is I'm going to make both of those slide to be parallelograms and then slide upwards to fill the other square. Let's call this anim A1 and we'll make it go from, well, let's say 0 to 100. So if I do A150, so if I make this a new command, so if we assume that the input goes from 1 to 100 and is how far across these have slid, so I want to go from there and go to, so it's going to slide over to meet up with that one. These 2 vertices are the 2 that have to move, and they're going to go to, got to slide across by 3, so that would be -3 and 1. Let's build that. Okay, so that is the parallelogram we're aiming for there. For the other parallelogram, we're aiming for these to slide down by 4. This to be take away 3 times #1 over 100 if there's 100 frames. And that wants to be -3 times #1 over 100. So that looks like that's about halfway between, so that's good. So this is going to be -4 times #1 over 100. So I'm now going to look at what I did last month. Let's copy that. In fact, rather than just dividing by 100, let's just make it take an input between 0 and 1. Animation divided by 20. Okay, so now that they slide into parallelograms, now we need to make the whole thing slide from there 5 units up diagonally. Let's copy this and this. I want to start from where this one ended, which is where this is 1, and I want to go to this but shifted upwards here. 3 that way and 4 that way. Then begin scope shift equals 3, 4. Just do shift this times #1, this times #1. Look, we go there and we slide upwards. And now for the final step of the animation, I then need to make those parallelograms slide up to rectangles so that they fill that square. So let's make another copy of this animation. Let's do an animation 3, and this is going to start. So let's just leave the shift 3, 4 on. Oh no, much easier. I can work out the equation of the line between the two parallelograms. The equation of the line, the equation of the black line, and work out where those two meet. This point becomes 0, 0, and this point becomes 3, 4. Is y equals 4x over 3. And then the other line, we've got y is equal to c, which is 3, and the gradient here is minus 3 over 4. X is 36 over 25. 36 over 25, and this is 48 over 25, this, plus that, values in, so these would be these times #1, plus this times #1, plus this times #1. Okay, I've typed a point wrong. From the starting squares to the parallelograms, push the parallelograms up and then up to rectangles to show that those two have the same area. And because you can slide the top and bottom of a square into parallelogram without changing the area, as long as you don't change the height, this shows that Pythagoras' theorem is true for this triangle, and you could make it show it's true for any other triangle by changing the shape of the original right angle triangle that we started with. What I want to do now for the animation is make it go back to where we started. We start off with two squares, they slide over to parallelograms, slide up to fill that square, slide back and slide back. We want to kind of stop at the completed square at the end and then stop again at the two separate squares at the end. So we'll put some A320s in. It's not 20, it's 1. There we go, it stops there for a bit because they're the starting frame of the first bit of animation. Yep, so we get to the end and then we stay on the final one a little bit. So if we're lucky, we'll run this convert to MP4 script and this will spit out a video file. So as usual, I will put the code I wrote to make this on GitHub. I'll put a link in the description below, and I'll also put a link to the finished animation and to the animation generation page. Thanks for watching. See you next time.